All right. So Unit 2 is about objects. And let me give you a little bit of background. Java is an object-oriented programming language. And objects in Java represent real-world things, things that can be defined in the real world, like you could have a book or a student or a menu or a phone or a car. These are things that we can create in software in Java. And we do that by writing classes. And a class is a template or a recipe or a blueprint, whatever you want to call it. Those all mean the same thing in this context for an object. So a class defines the attributes and behavior of an object. And we'll be writing classes. We just started, Wilder. We'll be writing classes in this class, and we'll use classes. Um, so you'll learn about all of this. We're not going to get deep into it. We're just doing like a little intro to it all in Unit 2. But attributes or properties of classes are stored in variables. They're also called data fields, but I like variables better. And that's like the int variable we made the other day, int x equals something. You can write a class, and like if you had a student class, you might have a first name data variable and a last name variable and a GPA or grade level or birthday. These are pieces of information you might store about a student. Or if you were doing a book class, you might have the title and the author. And then behavior of an object is determined by the methods, and methods are blocks of code that you'll see in just a minute. I'm going to get right. I'll show you specific examples, so it's not going to just be vague. But if we had a rectangle object, there might be a method where you could ask the rectangle, "Tell me your area," and then it would reply with the area or the perimeter. That's an example. Or yeah. So let's look at a couple more keywords or definitions. When you create an object, we call that instantiating an object. And we always use the new keyword when we're creating an object. So you'll see that in just a minute. You'll see how to do that. So, and just circling back around, a class is like a recipe for an apple pie. If I handed you a recipe for an apple pie, you're not going to eat that, I hope. Maybe you're hungry enough to eat the paper. But the idea of the class is you might create a pie by looking at the recipe, and you can create as many pies as you want using that same recipe. The recipe doesn't become less valid just because you created 100 pies. So, and when you create an object in Java, it's called an instance of the class. That's that instantiating. It means we've created an object, a pie object. And it's the same way as when you actually create an apple pie, that it's an example or an instance of a pie from a pie recipe. Okay, so let's talk about a specific example. If we have a rectangle class, which I'll be giving to you shortly in a REPL, and we'll do some things with it. Rectangles have two, in my world, rectangles have two attributes, the length and the width, right? That's, and we know they're right angles because that's the definition of a rectangle. So you might create a rectangle object in Java using this command. You say rectangle, and then here's a variable name. It could be anything. I just called it R1 to stand for rectangle number 1. Equals new rectangle, and then I'm sending over here the length and width, or width and height. I don't know which is which. Looks like width 20, height 40. So then once you've created it, that instantiates a rectangle object, and it sets those attributes to 20 and 40. And then I can use two behaviors, which are methods, that you'll see. I'll show you the whole class in a minute. If I say get area on R1, this is saying, hey, I want the area of rectangle 1, please, and print it. Then the code would go ahead and give me the area of that rectangle. And if I said I want the perimeter of rectangle 1, I would get that also. So it's going to make more sense once you see the rectangle class, which you will see soon. Any questions so far? Here it is. Here's the rectangle class. Let's take a look. A class always starts with the word class and then its name. You don't, in REPL, we're not going to write classes that say public, but you'll see that. In Java, when you write a class, you usually keep classes in separate files. So you'd have a rectangle class and it's in one text file, and you'd have a square class in another text file. And if you create a class with the word public in front of the word class, then that class has to exist in a file with that exact name. There'll be rectangle.java. But when we're in REPL, we're doing all of our coding. REPL has a program called main, a class called main, capital MAIN. And we always put our rectangle class below that. And so we don't say public class rectangle, we just say class rectangle. So for now, forget that public term. But here's a rectangle class. It's got two variables, and we'll talk about this private stuff later. Just ignore it for now. But here's an int for width and an int for height. And this section right here, this is called the constructor. And that's what gets called when you do that new command. It calls that code. And so remember when we created a rectangle, I sent over two integers, and they get put into these variables W and H, and they get stored then in these long-term variables, width and height. And then when I tried to print the object and said get area, it returns. That means it sends back to the caller the width times the height. That's the area of a rectangle, right? And when I call get perimeter, I get the width times 2 plus the height times 2, which is the perimeter, right? These last two blocks are called methods, and blocks of code are contained within curly braces, like we've seen in the little programs we've done. But this is a complete class, and we could and we will create rectangle objects today. I want to go back to here. You don't have to call it R1. You could call it Mr. Biggles. You could call it X. You could call it my first rectangle. It doesn't matter. You have to give it a name, and then whatever name you give it, you have to refer to it with that name going forward. But you do have to say capital R rectangle. Classes always start with a capital letter. You're able to write classes with a small letter in front, but the standard in Java is to capitalize classes. So you have to respect that. Rectangle R1 equals new rectangle, and then we send over the information. So here's that call again. I backed up, but I didn't know I had it forward. We create a new rectangle. That calls the constructor and sends over 20 and 40, and it instantiates an object in memory that we can then refer to. We can do things like ask it for its area. So then when we print r1.getArea, we get the area. Java prints 800, 20 times 40. Let's create a different rectangle. Rectangle big equals new rectangle 100, 3. That big is the name. And when we call that, it calls the constructor and sets the variables. And then this print call, big.getPerimeter, calls the getPerimeter method, and it sends back the perimeter, which is 200 plus 6, or 206. Questions? All right. So objects are actually variables, and we call them reference variables or class variables, as opposed to primitive variables. You remember primitive variables are int, double, and Boolean so far. There's other ones, but those are the only ones you need to know for this class. When you create an int, it's a primitive variable, and it doesn't mean it's lame, like primitive in a lame way. It just means it's the most basic type of variable. Primitive variables don't have methods. You can't call get perimeter on an int. It's just a number. All you can do is add it to something or use it in some way. For variable names, just a reminder, you can name an object any name that you could use with a variable, and variable names start with a letter, and they can be made up of upper and lowercase letters, the underline symbol, and numbers, but no spaces. You can't put spaces in variable names because Java doesn't know where the variable starts and where the next word starts. So, and you can't put a minus or a plus in a variable name, or a period, because those are things used in other ways, or a divide by or times. That makes sense, right? Because it would be like, oh, you're multiplying two things together. Okay, so I'm going to give you a program. It's got 3 classes in it: a square, a circle, and a rectangle. And then I'm going to walk you through creating a square object, and then we're going to and then there's an assignment where you'll create some more objects of your own in that same file. So I have to assign it to you now. So go to the Google Classroom. Let's see. I think I'll leave the video going for now so that the start of this comes through for people watching. Also, we do have more notes. In a second, I would encourage you not to go try to blow past. I mean, I just gave you the slide deck, but if you could wait before you try to do the rest of it all, that'd be awesome. So open up the REPL, and you have to fork it. So don't forget to log into your REPL, and I have to fork it like this. You fork it a different way, but if I didn't fork it, I would be changing the file that all of you would be opening, and I've done that. Sometimes I do the answer to the program in the program, and then everyone's like, "Oh, thanks for doing it for us, Mr. Hayes." Okay. So before you start trying to write a bunch of classes, create a bunch of objects, I want to show you where everything is. So here's class main. This one could have said public class main, because see, we're in a file. We're in a text file called main.java. So, but if you scroll down, this main class, if you click on this curly bracket, you could scroll down until we find that curly bracket ends right here. And now we have the classes I added right here. So there's a square class and a rectangle class and the circle class. So let's look at them. The square class just has one variable, the side, and I made it a double. So you could do decimal numbers with the square. And when you call the constructor, you have to send over a number. It could be an integer or a double, and it'll store it. And then if you get the area, you can get the area or get the perimeter on a square. The rectangle class we already looked at. So I'm scrolling down to the circle class. Circles also only have one piece of information that's required, the radius. And again, I made it a double. So when you create a circle, it stores the radius. And then you can also get the area. And I know we usually call the perimeter of a circle circumference, but I called it get perimeter here. Okay, so in this REPL, what I want you to do, here's an example square. And I want us together to make a square. So right here, if you would, square, and what should we call it? I'll call it demo equals new square. And then we need parentheses. So if you could all do this right in that spot. Remember, you have to fork the program first. Anyone need help forking? Are we good? So remember, a square takes a double. I'm going to say 1.414, and we need a semicolon at the end. And then I want to it says add lines above to create and then print the area and perimeter for a square, a rectangle, and a circle following the examples I gave you. And it has more information. I want to print system.out.println demo.getArea. So, and I want you to do that as well, and then run it. And we'll get first the area and perimeter of that square, which should be 100 and then 40. And then I was typing in as much as I could remember of the square root of 2, which is 1.41 something. And look, it's pretty close to 2. I didn't quite get up to 2, but that's the area of that square. You could copy the code I did here, which is pretty nice. It says which object it is and then what I'm printing. You don't have to, but now the assignment is for you to make your own square. And then I want you to print the area and the perimeter. I'm gonna switch to using the ones that I made before because they're prettier. And you can do the same, but that seems good. So now your assignment for this is to create a square and then print the area and perimeter of your square. Create a rectangle, do the same. Create a circle, do the same. And then run it. Make sure it runs. Make sure it prints nicely. And I'm going to pause this video and we'll resume it after. So back to this. We're going to talk just a little bit about parts of classes called constructors. Just want to recap what we just learned. Classes are the blueprint or the recipe for objects. When we create an object using the new keyword, Java instantiates an instance of a class in memory. That instance is called an object. So that's a lot of interesting words. You'll get the hang of it. Here's an example. Square, my tiny square equals new square 0.001. My tiny square is an instance of the square class. My tiny square is also an object. We could print it. We can call its methods. Questions? Yes.
The class is the bit below that you wrote before, right? Okay, make sure.
When you create an object, you are actually invoking a constructor, which is a special kind of method, and the methods are what define the behavior of objects. Constructors have exactly the same name as the class they are in. I'll show you. Here's the square class from, it says from last class, but here's the square class we were just using. So the constructor is right here. I put a box around it. The constructor always has the word public. It has to. Public, and then the name of the class. And then it may or may not have something inside the parentheses. In this case, when you create a square, you have to say how big it is. So there has to be something in there. A constructor always has the exact same name as the class. It always has the word public in front and then the class name, and the case matters. A constructor can require one or more input variables called parameters, and the order and type of those parameters are called the constructor signature. In this case, the constructor for the square just has one parameter, a double variable. But in some classes, you'll end up with more than one constructor, and they might have different signatures. For example, you might want to be able to create, let's see, here's a book. You might want to be able to create a book object even if you don't know the author or the year it was published. So you might have one constructor that just takes the title, or another one that takes the title and the author, another one that takes the title, the author, and the year published. That's easy enough. And when you do something like that, it's called constructor overloading. In this case, overloading isn't bad. It just means you have more than one of that same thing, and they're different. You tell which one is which, and Java tells which one is which by looking at the signature, which is what variables are in the parameter list. So I'll give you an example of that. Here are 3 different possible square constructors. We just had the first one where we sent over a double, but let's just imagine the square class also had a color variable for what color the square was. And if that's the case, you could have all three of these different constructors. This one just makes it makes the square the size you asked, and then always makes it blue. So you're like, hey, if I want a blue square, I'm just going to send over the size. I don't have to say also blue. But here's another constructor for the square class. See, it has string C and double S, and has a different signature. It's not just double S. And Java knows, hey, if you send over a piece of text followed by a number, it knows to go to that one. And then just for to show you it can be done, I made one that doesn't take anything, and that makes a one-sided square that's blue. So Java figures out, like, so in this case, if you called square without putting anything in the parentheses, it would call that one, and you'd have a one-sided blue square. I want to be clear, this one-sided blue square and the one with the color, this wasn't in the class that we've already worked with, but I'm saying if we had a color variable, we could have these different parameters. And Java figures out which one to use depending on what you write here. Here's 3 squares. I say new square with nothing in it, it's going to call the one with nothing in it. New square with just a number, it's going to call the one with the number. And new square with a color followed by a number, it calls that one. So this call square S4, new square yellow, that's not legal. Can anybody imagine why not and say out loud? Raise your hand, I'll call on you. Matthew?
You need a side defined or a side.
Yeah, there is no constructor listed here that just takes the color. So we could write one, but given what I've shown you, there isn't, you can't make a new square and just say, I'm making this one yellow. And I don't care what size it is, because that's not one of the ones that there. You could write that, but it's not in the class. So the way I wrote the class, there's only 3 ways to create a square: send only the side length, send the color and the side length, or send nothing. That's constructor overloading. So finally, this one is valid, but it might seem a little strange. You can say square S5 semicolon. And you're like, what? What does that do? Well, that creates a place where you might store S5, but until you store anything, until you do the new part, it's going to be null. And null means nothing's there. So it kind of only does half the creation. It stores it somewhere, it gives it a name. And before you use the square, though, before you try to get the area or the perimeter, you have to do this call. You have to say on a different line, S5 equals new square, and send over a size. If you tried to do the get area or get perimeter before you did the new command, then you'd get something called a null pointer exception. It means you're trying to make something that doesn't exist tell you about its area. So Java's just not willing to do that. So when you're creating an object, you have to use the new keyword somewhere, or it doesn't work. Okay, so now I'd like you to do the day 7 constructor practice REPL. I'll post it in just a second. And in that one, you're going to create different student objects. And you'll have to look at the student class and then do what I'm asking. And then after that, and you can start it in class if you want, I want you all to watch 2 videos from the AP classroom. The 2.11 and yeah, I've posted the wrong video online. It's the 2.1 first video and the 2.2 first video, and so don't do that yet. And I can tell if you watch them. The AP classroom tells me if you watch them. So I'm just it's like 10 minutes total of time. So if you could watch those 2 videos, and like I said, I don't mind if you start watching them here, but it might be easier where you could put earbuds in, or so what you owe me before class starts Friday, or really today, are the first 2 things, and then watch the videos. And I will post the constructor practice and and I'll walk around and help you with it. And you've got the slide deck already that has everything we just were looking at. I'll post the AP Classroom. And as I said, I did notice I assigned the wrong thing in the AP Classroom, so I'll go fix that right now. So in the student class, you have to look at the code down below. That's where the constructors are. There's 3 constructors in the student class. One just takes a name, one takes the name and the grade level, and one takes the name, the grade level, and the GPA. So I'm asking you, I put it up here. I tell you what I want you to do. All right, that's it.